So these guides, along with good process, all of a sudden, high performance is easy.
You know, this rethink towards net zero is rethinking a lot of the traditional building enclosure assemblies and building them better.
I get excited, but I also get depressed. I'm depressed because I'm old. And if I was younger, I would embrace this opportunity for this change. I see the young builders, and to me, I get excited for them.
Morning.
How you doing, Graham?
All right, James, what we got here is LEEP wall number 4. And LEEP wall number 4 is a deep or double stud wall with cavity fill insulation, no exterior insulation in this application. And the way we're getting our R value towards our net zero targets is we're making this wall fatter and fatter and potentially adding in a service wall, an additional wall on the inside. So the traditional approach to this double wall is a 2x4 framed walls. The cavity is filled with insulation. We'll get into the insulation, and you leave a gap between the two stud walls to get your R value. So you need more R value, you just increase the gap.
Sure.
And so when you're getting in, and you imagine this during construction, you've got double wall framing. It's going to be very difficult to, cut and fit in bats, just, from an installation standpoint. So typically this cavity is filled with dense pack cellulose. You can use dense pack fiberglass, you can use open cell spray foam, or all sort of variants of this. But with dense pack cellulose, you're packing this into this wall assembly here, usually 3.5, 4 pound density to get enough density so that it doesn't settle in this cavity.
Yeah.
You can see here we've got a cutaway showing the cellulose packed in for this mock-up.
That's friction on the side, just on the density.
Yes, you need to be tight, and it should be as tight as your mattress. I mean, this is not quite tight enough here, and if this mock-up were to sit for a long period of time, that insulation would probably settle down.
Yeah, I'd need a new mattress.
Yeah. You'd be sleeping on the floor, yeah. James, we're at wall 4, and just wanted to clarify some of the questions about air and vapor barriers with a double stud wall.
Good idea.
Yeah, so traditionally with a framed wall, we put the air barrier and vapor barrier on the inside. And it's no different with a double or a fat wall, right?
That's been our past program.
Yeah, and although in recent years, we've started to use more modern approaches with exterior air barriers, right?
Agreed.
So house wrap.
Agreed.
Now the risk with making in the house wrap the only air barrier in a double wall is that if air gets into this deep space and it's really cold in here, then we can get condensation. And so in a lot of these double walls too, we have cellulose. Now, typically cellulose, we try to get in at 4 pounds a cubic foot. What's your experience getting that cellulose tightly packed into everywhere though?
I find it, and it goes to a basic principle. My experience is the densities are inconsistent, okay?
Yeah.
The principle that I try to work and live by is everything I do is in front of me. This is a blind install.
Yeah.
You can't see what you're doing. So you're
yeah.
relying on a density test after. You don't know if it gets hung up or what's happening inside that wall assembly. It can and has been done successfully for me also.
Yeah.
So don't get me wrong. But I've also had success. The last job came in at 2.9 and I asked for 4. And I was like, okay guys, it didn't really quite work out. It's very important that we get a good dense pack for convective looping purposes. You can talk about that, convective looping. That's something I read in the guide.
Yeah, so with these deep walls with fibrous insulation, there's the risk that, with cold air following in the sheathing and warm air rising on the inside, we're going to get this looping inside these wall assemblies where it can bring with it moisture. And so it's important to have interior air tightness. The other thing the interior air barrier in this case is also doing, this is plastic. We're using polyethylene or potentially a reinforced polyethylene, another product here on the inside. This is also performing the function of our vapor barrier. So it's the same as before. It's an air vapor barrier. And it's only an air barrier because we're doing a really good job of detailing. We're going all the way from our foundation. We got styrofoam on the inside of our concrete wall. We've taped all the joints. We've taped the joints in our rim joists. We got the transfer through the acoustic seal to the poly into our windows and tying into our window frame here.
That's fine, but my experience is that's also difficult with all the amount of penetration on the inside. What else can you do?
That's
if you want to make it simpler.
Yeah, and what we're really seeing with a lot of the higher performance double walls we're seeing with passive house and net zero projects is we're seeing in almost every single case, builders build a third wall, a second wall on the inside or a service wall, right? And the service wall, the idea with the service wall is your air vapor barrier is left here. And a 2x4, 2x3, even 2x2, it could be vertical, it could be cross-strapping, could be whatever. Essentially built on the inside here, you got put a bit more insulation for our value, why not? But you run all your services in here, and the air barrier doesn't even get touched.
Well, that's a good idea. I suppose you could put a OSB or something here also and keep it in hardboard, or is that necessary?
Yeah, actually, a lot of builders are also looking at alternates to plastic, right? They're looking
Yeah,
at
yeah.
alternates because
That's why I asked the
polyethylene
question. That's what I'm hearing.
hasn't served them well, so they look at OSB as a rigid air barrier for higher performance, and it can seal up and detail really well. OSB is really unique in that it is, when it's dry on the inside, it's a vapor control layer. It's a vapor retarder. It's about a perm when it's dry. And it's also, most OSB is actually airtight, or airtight enough to be.
Well, that's good. So tape the joints and we'd serve what we need.
Yeah.
Thanks. I appreciate that.
Yeah. The concern that a lot of builders have is, well, if I have sheathing on the inside, why do I need sheathing on the outside? The way this wall works to get, your R values is you increase the thickness. You look at the type of insulation, and in the LEEP guides, we've covered different types of insulation and gaps. If you want to even use 2x10s or 2x12s, or if you really wanted to go crazy, then you can use that as well. And we'll get into some of the details later on. One of the other ways to increase our value is you build a service wall on the inside of this wall. So if we look at the detail here, we got our double wall. It's good there. Double wall. And so we got, like, say, R30 here, and we need another R10. We just build another wall on the inside here, and we get R10 on the inside.
And all the services run here, so we don't affect any of the air barrier.
Yeah.
Or minimally affect the air barrier.
Yeah, let's talk about the air barrier.
penetrations.
Yeah, let's talk about the air barrier.
There's an interesting air barrier approach here.
Yeah, so with our deep walls in Canada and the cold climate, we need some degree of air tightness on the inside. So we can put the air barrier for the building anywhere within. We can put it on the inside, the outside, we can put it somewhere in the middle, we could put it, a whole bunch of different locations, right?
The common approach with the deep walls, you want to get a primary air barrier on the inside.
Yeah, what you do with a deep wall is you don't want warm, moist air getting in and convecting, and what will happen is the air will flow through this, so hot air rises, cold air falls, and you get convective looping inside these deeper walls, especially if there's gaps in the insulation. And so what you want to do is you want to have an air barrier on the inside of these wall systems, so you're managing that air flowing in there.
Wouldn't a dense pack itself prevent that convective looping?
Definitely,
If you manage to get the density everywhere?
Yeah, and one of the reasons people use dense pack cellulose is it does fill all the gaps. If you're using bats and you're shoving it in there, you're going to end up with some gaps. And those gaps are bad to the performance thermally, but also from a moisture standpoint. Yeah. So with the air barrier on the inside, one of the challenges, as you know from traditional construction, is you got plugs and other penetrations and outlets, through this wall.
Lots of them.
Lots of pot lights in the ceiling, right? And so one of the strategies we've seen quite successful is you keep the air barrier there, whether it be polyethylene, reinforced polyethylene if you're blowing in behind cellulose, or smart vapor retarder in some cases. There's a whole bunch of different products you could use here.
But you're going to use a blow-in system that's conducive to the mesh or poly or whatever you're using.
That's right.
Because there are different ones, right?
That's right. Yeah. If you're blowing in cellulose, traditionally you need a mesh here. It's air permeable. You blow it in, and then you have to put another poly vapor barrier afterwards, air barrier afterwards. There are systems now that allow you to blow in. They basically neutralize the pressure on.
So air release at the same time blowing in, so you can use something like this or maybe what we'll talk about down there.
That's right, yeah. And so this, the polyethylene's a good air and vapor control strategy for this wall.
Right.
We also see, a lot of builders using OSB or plywood sheathing. And so OSB or plywood sheathing, when they're on the warm, dry side of this wall assembly, are actually function as a vapor retarder. They're actually smart vapor retarders because the permeance,
Permeance varies with humidity.
That's right, and actually on the outside, it's quite vapor open, but if you use it on the inside, it closes in, right? And so we see a lot of walls where you use OSB or plywood instead of the polyethylene as your vapor control and your air barrier. So one of the ideas with the service wall is you got all your insulation in here, and then for all your services, plumbing, you don't even need to run your plumbing through the interior walls. You can run it through the exterior walls if you wanted to. All your electrical outlets, everything, and you plug it into this wall here, and the air barrier is now protected by this service wall.
Yeah, right? Except for the occasional penetration, which you can then detail.
That's right.
And so services,
so that's the idea here. So, and so when you're looking at this wall assembly overall, the R per inch of this, the cavity insulation is lower than, the rigid insulations we covered with the other walls on the outside. This is 3 to 4 per inch.
I noticed something on the inside here that on this mock-up, I think shows a couple of different approaches where we clearly see the interior air barrier coming through and connecting to the window, to the plate here. But down on the service wall, we also see a compartmentalized approach for this area here. Any reason, can you explain what the concept is? That's to help reduce the potential for convective looping and this kind of stuff?
So for this wall assembly, to get the R value you need, whether you're building in Winnipeg, BC, wherever you are, you're going to be adjusting the depth of this wall. Okay, and typically the R value per inch of fibrous insulation like cellulose and fiberglass, 3 to 4 per inch, maybe a bit more than 4 for some of the high density products. And so you can do quick math to figure out, all right, if you need R 40, what that thickness is going to be with all the thermal bridging and everything in there. So these walls tend to end up being pretty fat. And so for higher R values. And so when you think about service wall and other cavities, you end up with a fairly thick wall. And so what you're trying to do is you're trying to minimize the amount of thermal bridging through all the wood. And that's why you tend to have a gap between your double walls there. And then the service cavity wall here will be pretty lightly framed. You don't need all the extra framing that you would use not supporting the rest of the wall.
And the inner wall can be like 24-inch centers, as long as the openings line up and everything like that.
Yeah.
And this would be your structural wall on the outside.
Yeah, that's a good point. Yeah, so typically the exterior wall, the exterior framing, I should say, is your structural wall, and the interior is tilted in after.
Right. And using the plywood as your plate connections.
That's right.
Between the two walls.
Yeah. So on the mock-up here and then the guide, we talk about 2 air barriers. And the reason we've shown 2 air barriers is we want interior air tightness. But we also appreciate that a lot of builders are getting really good at building exterior air barriers really tight. So using the house wrap or the sheathing as the primary building air barrier. And this is really in the inside for your walls for keeping that convection from happening, but also could form part of the overall strategy. So what you'll see in the details is you've actually got exterior air barrier details here and interior air barrier details. So we're going to go spin this around. So on the outside of this wall assembly, to a builder, it looks exactly the same. You wouldn't know looking just at this, what the R value is in behind here. And so one of the benefits of this deeper wall system is on the outside, and what we got shown here is a rain screen wall system. On the outside, it's pretty traditional. We're showing a rain screen wall in the LEEP guides for moisture reasons. Right? The main reason is we want to provide a bit of extra drying capacity here. When we add more and more insulation on the inside, that sheathing gets colder and colder.
Sure.
And so it's at risk of condensation, or it's at risk of getting condensation on it from air leakage or vapor diffusion. So we want to have that outward drying capacity. But also if we get rainwater leaks, say around a window flashing detail, that rain screen space and the cavity and the airflow and the drainage that's provided, which is common in wetter parts of Canada, provide that benefit. So when we switch to these deeper insulated walls, we're going to see a lot of the time rain screen type cladding attachment or systems.
Which makes sense. I mean, if you increase the risk of something, then you should provide something that can manage that risk. And so if you can have potential moisture or issues of condensation, you put the rain screen on. It's really quite simple to do.
Yeah. And so when you look at your details here, so if you're familiar with house wrap as an air barrier, you can see that starting here at the foundation. So we've got, in this particular wall, we've got a concrete foundation wall with potentially a damp proofing on it, or just moreover just bare concrete. We got a peel and stick transition to go from the concrete to the wood. We got a flashing in here that we've taped, or we could seal it to the flashing, but essentially transferring the air barrier from the concrete to the peel and stick through the flashing into the house wrap. And then we got air tightness into our flashing around our windows, window flashing details all the way to the top of the wall.
Back through.
Yeah, and so with the double wall here, we've got there's many different ways to frame a double wall. You may end up, if you're doing 2 2x4s and you wanted to tilt them both up at the same time, you would use essentially plywood plates. So you do it all at once. You could also tip out the outside one like traditional and then the infill on the inside, but we've shown it here for mock-up with plywood. And so we need to transfer the air barrier from the outside to the inside of this detail. So we got polyethylene air barrier in the ceiling, air barrier out here. We do have the polyethylene air barrier on the inside here as well, and that transfers super easy, right? You got air barrier, acoustic sealant, and then we've got poly, and then the drywall, when it gets installed, squishes it all together.
Similar to the plate concept, just using the plywood to...
Yeah, so the plywood here is transferring. So if this is our primary air barrier, then we've got that transfer through the top. And it's still wet, thank you.
Oh, did you get it?
Yeah, I got it.
It's an amazing product, acoustic seal, because if it's wet, somebody will find it, okay?
That's right.
Yeah.
It's usually in my hair. So.
The some interesting air barrier transfers here using the wood framing, etc., at the inside corner. Just shows some of the flexibility.
Yeah, great observation. So, working with polyethylene as the air barrier here, most drywall installers are going to shred, this when they cut out the drywall around your windows.
Rotozips in town,
Exactly, right? So, the acoustic caulk is here on the face, transfer through. The polyethylene should actually run down here to the floor, but there's a couple different, you can transfer it through like we've done here to the plate, the bottom plate, so everything's sealed up
transferring through the wood. It's a mock-up to look at options. So
yeah, so there's different ways to do that. But you can see here we've tied in the polyethylene to the wood here, and the idea is that the wood buck here becomes part of the air barrier.
Sure.
And then you can see the transfer through to the tape here, and then we've got the sealant on the inside of that window frame that's forming the air barrier on the inside.
You just X-cut the poly, that's how you ended up with the V's. So it was actually made simple by just cutting the flap in.
Yeah, so you're getting some redundancy in there and really improving your polyethylene air barrier detailing. So you're actually getting transfer into the wood and then into the window.
Mm-hmm.
So James, you'll notice this window is installed right in the middle of this wall.
Mm-hmm.
So one of the nice things about a deep wall like this, and we've used a 3/4 inch plywood buck around the opening.
Liner,
Yeah, liner, basically span across between the outside framing and the inside framing. And deeper wall, just deeper buck. And if you had a service wall, your buck would come out even further. Okay, so with our non-flange window here, we can install it anywhere within that rough opening. If you have flange window, potentially on the outside. If we wanted a flange window, you could buck out this with framing and install the window on that. However, that creates a whole bunch of other complexities.
That's a very complex way to go about something that could be simple.
That's right. So non-flange window allows you that flexibility to install it wherever you want in that rough opening. One thing you'll notice down here is this is flat, right? And in areas where potentially a lot of water is sitting here, we potentially want to add a bit of slope to this. And so we could actually slope the bottom quite easily by putting this on shims, right? Or taper cutting this, or building up on top of the peel.
Well, the back dam angle is kind of advantageous, that it would even by volume.
That's right. Yeah.
Drain forward, not instead of backwards, and on a waterproof membrane, the amount of water is usually minimal.
Yeah.
Would dry.
Yeah, so this window here, we've installed it with back dam angle peel and sticks coming up and over down the face, traditionally wood, and it's got clips on the inside and back rod and seal. And there's lots of different ways you can install this, but generally you want to get that window in the middle of this wall assembly. That's the best place for your R value, and actually for minimizing the thermal bridging.
And attachment is quite simple if you simply have a plywood liner for your return claddings, etc.
That's right. So this wall really, it takes a lot of traditional approaches, from exterior water and air barrier detailing, interior air barrier detailing. It's just fatter. Right? It's just, it's stretched out to increase the R value. You're using typically insulations that are lower cost, per R value, just because they're fibrous and blowing in, versus a rigid product. When you look at this wall assembly, it's something that, some homeowners can even build themselves, right? You look at the detailing here, it doesn't require, a lot of special tools, and it's something that you can take on as a do-it-yourselfer even.
Yeah, no, I understand. This wall is built in quite a few places across the country. I believe it's quite prevalent in Alberta. It's kind of, I find it just amazingly interesting that across the country we have different wall types and technology and understandings for each of the various regions. It's one wall type across the country that doesn't exist. And so I think LEEP is really helping to unify high performance for whatever you want to build. As a starting point. So.
One of the good things I've heard from builders about this wall is how cost effective they can make this. A lot of builders see a deep or double wall is a lot cheaper than one with exterior insulation. You know, they do look at the material cost, and you know, this type of insulation is a lot cheaper than rigid insulation.
There's still nuances and considerations when you build an interior deep stud wall, okay, which could come back on you. So you really need to understand that.
Yeah, let's walk through those.
It may be costly at day one, but if it doesn't work well because you avoided some consideration, then it's not cost effective.
That's right.
So.
Yeah, so this may be cost effective, but this wall requires very good air tightness.
Right,
the details
on the inside.
That's right. It's critically important to get the air tightness right. If you don't get air tightness right with this wall, it is at higher risk than an exterior insulation.
Yeah, and that was my point. So.
Yeah. So James, you'll notice this wall assembly, we've shown a rain screen.
It's a capillary bag from the water shedding surface to the water resistant barrier, okay? Provides drainage and drying potential.
That's right.
For whatever moisture may, from whatever source, accumulate.
That's right. And so the idea with a rain screen wall, or rain screen cladding on this wall assembly, is to provide that extra durability to allow drying of that sheathing out. The sheathing is going to be colder and therefore damper, and with all that insulation on the inside. And so in our wetter and damper climates, it's very important to allow that outward drying.
Yeah.
When we see even double stud walls and deep walls built all across Canada, you know, they're building above code anyways, and we're seeing most of them actually use some sort of rain screen approach, because the builders will actually appreciate that they need some drying there and some bit of redundancy when they're building a higher performance wall system. So in our deep and double walls, from a building science perspective, we got our sheathing on the outside, got our vapor control and air control on the inside. You know, outdoors cold, warm indoors. And so this sheathing with all this insulation on the inside is actually quite a bit colder than we used to have with, like, you know, our 20 or 22 bats, right? We got our 40, 50 on the inside of this now. That sheathing becomes appreciably colder and closer to the outdoor conditions. As that sheathing becomes colder, the humidity actually goes up around on the inside and on the outside, and so the moisture content in that sheathing tends to be higher in these double walls or deep walls than maybe, you know, traditional assembly. So because that sheathing's colder and the higher humidity and higher moisture content, any small leak now can push it over the edge. So this assembly, if you're not careful with air and vapor control, can be riskier than a traditional approach. And so that's why we had taken all these steps to put, you know, improved air barrier detailing. That's why we'd look at using the service cavity here. And the idea with the service cavity is it protects the air barrier.
And rain screen.
Exactly, and the rain screen. And so the LEEP approach to this wall has been, you know, good air barrier details. You can protect your air barrier details with that service cavity on the inside, especially as you start getting into needing R30 to R40. It's going to make sense to do this anyways. You know, R35, depending on what you're putting in here, is going to be a gap anywhere between 2 and 4 inches, you know, somewhere in that range. And so if you're looking at mid R40s, you know, it's that plus this assembly on the inside. You can even look at 2x6s, and, you know, there's all sorts of different ways you can construct this.
Quite a bit of real estate to get a
right.
wall.
Yeah.
You might want to consider that too, I guess,
Yeah.
if you're going to build
Or
it.
you're looking at higher, you know, the reason to use a high density dense pack cellulose is you get a higher R per inch out of that dense pack
Thin it up
than
a
you
little.
would with say a fiberglass or something else that's blown in.